This is number 72 in Chapter 7. It's looking at emission spectroscopy, looking at the energetics of electrons relaxing from a higher quantum level to a lower quantum level, and the light that's actually produced, or the photon that's actually produced as a result of that relaxation. And so 72 looks at an electron in a hydrogen atom relaxes to the n is equal to 4 level. So we're relaxing to this level, so that would be our final quantum level of 4, and it emits light at 114 terahertz. So that's a frequency. And so given this information, what is the value of n for the level in which the electron originated? So we are trying to figure out what is n initial, given the fact that we have the frequency of the photon being emitted, and we have the final quantum level that the electron relaxes to. And so we really want to use two expressions. We want to solve for that energy of the photon, and we can do that by simply taking Planck's constant times frequency, and then we need to relate that energy of the photon to the energy of the electron transition, or the electronic transition. And remember, that's an equal in magnitude but opposite in sign, so that's why we have the negative energy of the electron. And then the last equation that we want to use is relating the energy of the electronic transition to the actual quantum levels which is the Schrodinger equation, where we have our negative 2.18 times 10 to the negative 18th joules times the difference of the reciprocal quantum levels and the square of those reciprocals. So we want to take 1 over n final squared minus 1 over n initial squared. So first we're going to start here, and then we're going to move to that equation. And so to begin, we'll start with our energy of the photon. That energy of the photon would be equal to Planck's constant times the frequency, which would be 114 times 10 to the 12th reciprocal seconds. And so we can solve for the energy of the photon to be equal to 7.5536 times 10 to the negative 20th joules. And that would be joule per photon. So if that's our energy of the photon, the energy for the electronic transition would just be the negative of that value. So now we have the energy of the electronic transition using equation 1. Now we can plug that into equation 2 and solve for our initial quantum level. So if I'm using equation 2 now, I would have my energy of the electron to be the negative 7.5536 times 10 to the negative 20th joules, and that would be equal to our negative 2.18 times 10 to the negative 18th joules times 1 over 4 squared minus 1 over n initial squared. And that's what we're trying to solve for, that initial quantum level. We bring over the 2.18 and do the division. We get 0.03464 would equal 1 over 16 minus 1 over n initial squared. We bring over our 1/16 and we get a value of negative 0.02785 equals the negative of 1 over n initial squared. So those negatives are going to cancel out. So we both have a positive value. And so we take the reciprocal of that, we get 35.9060 equals that initial quantum level squared. We need to take the square root of both sides and get n initial to be equal to 5.99, or roughly 6. So our electron begins in the principal quantum level of 6 and then relaxes to the 4th quantum level, and in doing that releases energy equal to a photon of frequency 114 terahertz. That is number 72.